Hi, welcome you all to the next daily capsule for today from physics. Today's topic is capacitor. So we are going to do three problems from capacitor. All three problems are important. These three problems are already asked for different examination in a different pattern. So if you understand the concept clearly, surely you able to answer this question in the examinations. So please listen to the question. Equivalent capacitance of the system shown in the following circuit is. It's a very straightforward question. There is no complexity. Only we want to know what is series and parallel connection. So let's have a look into this one. So we need to find out the equivalent capacitance between, of course, the point A and B. So what we can see in this figure, we have two capacitance. Let's say this C1 and let's say this is C2. Let's say this is C3. C1 and C2 are in parallel connection. So what is the total capacitance in that case? So C equivalent equal to C1 plus C2. This is the total capacitance. So what is the value of this one? It is 3 plus 3. This is equal to 6 microfarad. So this capacitance is in what connection? This capacitance is in parallel connection. It's in parallel connection. Important or not? When it is parallel, it is C1 plus C2. So of course you have a doubt. What is the formula for series connection? You may already know if you have well prepared. C1 plus C1 C2 divided by C1 plus C2. C1 C2 divided by C1 plus C2. This is connection for series connection. Now we find the equivalent capacitance. Now our circuits look like we have a 3 microfarad overall here. And already we find the next capacitance value, that is 6 we already calculated. Now our point A here, our point B will be here. Now we need to find the total capacitance for this 3 microfarad and for 6 microfarad. So 3 capacitors now change it to 2 capacitors. One in the value, it's 3. The second one value is 6. This capacitance is in what connection? It is in series connection. It's in series connection. So we are going to use the series connections formula here. What is the series connection formula? We know C equivalent equal to C1 C2 divided by C1 plus C2. So let's multiply. So this 3 and this 6 are in series connection. So 3 into 6 divided by 3 plus 6, which means 18 divided by 9, answer equal to 2 microfarad. So 2 microfarad is the correct answer for this question. Simple ana, it's a combination of parallel plus series combination. So answer is equal to 2 microfarad. I hope this question is understood for you. If you have any doubts, please post it in the comment sections. We will try to answer your doubts. So let's go to the next question. This question is not simple. At the same time, if you have learned this correctly, it's very easy. You can answer it in less than 30 seconds. If you are learned this question very correctly. Let's see the question. What's given in the problem? There are 4 plates of the same area A are joined as shown in the figure. The distance between the successive plate is D. Find the equivalent capacity across P and Q. P and Q. When you see this diagram, immediately you have to draw the equivalent circuit. How we can draw the equivalent circuit? That's very simple. Let's take one point P here. Let's take another point Q here. Then you must understand capacitance exists between different plates, not on the same plates. Let's say the first plate here to second plate. These are the different plate. One is P, one is Q. You have one capacitor. And between Q and between next P, you have another capacitor. And between P and Q, you have next capacitor. Okay. Now you know these all complete. This wire is completely called P wire. This wire is completely called P wire, and the next one is completely called Q wire. Everywhere it is Q. So if two metal plates are coming nearer to each other, then there is one capacitor. Now I'll put this capacitance as C1, this capacitance as C2, this capacitance as C3. Now let's draw the diagram. First capacitor P to Q ആണ് C1 വരുന്നത്. So P to Q ആണ് C1. C1. First capacitance. Next capacitance നോക്കണം. So this point is Q and this point is P. So we have P, Q, P. We have the second capacitor, right? Upper plate is Q and the lower plate is nothing but your P. So lower plate is nothing but P. Lower plate is P. Upper plate is nothing but your Q plate. So C2 is the capacitance between Q and P. So Q and P. So that's the next capacitance. Q and P. So we have C2. Then we look for C3. C3 is this capacitor. This is called the C3 capacitor. So how the C3 capacitor is coming? I zoom the diagram. It's more clear to you. So I'll zoom it. So now you see where is C3? C3 is the capacitance between the upper red plate, that is P, and the lower blue plate, that is called our Q. So between P and Q. So let's draw here between P and Q our next capacitor. What is the called? C3. That's all. So the diagram is over. This diagram is we are changed to a simple diagram. So upper plate is completely P ആണ്. So first P plate, if you are looking from the top side, first P, then Q, then again P, then again Q. So we have 3 capacitor here totally. Now you say, now it's easy for you to say these capacitance are in what connection? It is nothing but in series connection. Sorry, in parallel connection. So all the capacitance are equal. It is given in the question. What is the value will be here? C equal to epsilon A by D. Why it is epsilon A by D? Because it is a parallel plate capacitor. If you look for the options everywhere, you can see epsilon A by D, epsilon A by D, epsilon A by D. And the distance is D. Distance D is the distance between 2 plates. A is the area of cross section. Now you know 3 capacitance are in parallel connection. What is the total equivalent capacitance? C1 plus C2 plus C3. So C plus C plus C. Answer equal to 3C. What is C will be here? 3 into epsilon A by D. So the correct option for the question is option number 3. This is the correct option for the question. That is epsilon A by D is the correct option. So this question is very important. You must understand how you are formulating or you are deriving our easiest and the simplest circuit diagram from the given plate diagram. So that is a key point. Once you understand this one, it's very simple. You can able to answer. Okay. So let's look into the third variety problem from capacitor. It's a theoretical based question. The plates of a parallel plate capacitors are maintained at constant voltage by a battery as they are pulled apart. What happens to the strength of the electric field during the process? So we have a capacitor plates. Say we have 2 parallel plate capacitor plates. Now they are maintained at constant voltage and later they are pulled apart. Pulled apart means what happened to the distance between the 2 plates. First it's D. Now the D is increased due to the common voltage. They are pulled apart. The question is given. They are pulled apart. So they are moved on either side. So distance D increases. So now what happens to the electric field? We know the formula called Q equal to CV. Capacitance into voltage. Why I am taking this formula? Because question is given me 2 hint. One is I am maintaining at a constant voltage. So my formula should have V. And it is a parallel plate. So this given hint is saying that it is C, and this is giving an hint saying that V, and question is asking, hey, tell me what is the value of E. E is indirectly connected with the charge called Q. So from the question I derived the letters capacitance, potential, electric field or the charges. Now Q is equal to CV. We know the electric formula. Electric field is directly proportional to charge. When charge increases, electric field increases. So let's see what happened. So what is C? C equal to epsilon A by D into V. And this is nothing but our Q. Now question is talking about because of the constant voltages, the plates are pulled apart. So which means D increases. When D increases, what will happens to charge? When charge decreases, this indirectly give rise to the electric field. So what happens to the electric field? Electric field also reduces. So the simple hint is D increases, charge decreases because D increases. So when charge decreases, electric field also decreases. Option number 2 is the correct answer for the question. I hope today's daily capsule is helpful for you to solve further problems in the NEET examinations for the topic capacitance. Let's see with another topic in the other day. Thank you for watching.